If tangent xy equals x, then what is dy dx? So tangent xy is equal to x. Take the derivative of both sides. That's going to be secant squared xy times x dy dx plus y dx dx, which comes out to 1, is equal to 1. All right, I'm going to rewrite. This is x dy dx plus y over cosine squared xy is equal to 1. I'm going to multiply both sides by cosine x dy dx plus y equals cosine squared xy. X dy dx is equal to cos squared xy minus y. So dy dx is equal to cos squared xy minus y over x. Okay, if you went about that a different way, and you could have ended up with something that took a whole lot of cleaning to do, all right, with a lot of trig involved in it. So this is where I'm saying you really need to know how to manipulate things, because you could have had the exact right answer on everything and just not in that form. Okay, it could have stayed in secant, and you'd have been doing some common denominators and stuff like that. So just, if you start working and you're on a multiple choice question and it's like a ton of work, you might think, could I have done something a little differently that would have made it look easier?
Was that the chain rule? That first rule you did?
This right here is just the chain rule. So the outside is secant squared xy times the inside, the derivative of the inside.
All right.
Okay. Number 2. Any questions? Any other questions on that? All right. Xy squared plus 2xy is equal to 8. All right, so we're going to do the derivative of this. You guys with me back there?
Yes, sir.
I'm going to start calling names, and then I'm going to invite your parents to listen to the video. And I'm going to say, just listen to how many times your child's name comes up.
But they were talking about
Charles
studying
Edwin.
tonight.
Okay.
So
All right.
it shouldn't be too much.
X. Taylor, I've had enough of your common sense approach to discipline. All right, that was Taylor. All right, here we go. So we're going to do the product rule here. So I'm going to take the derivative of x times y squared plus the derivative of y squared times x. So this is y squared times the derivative of x is just plain old 1 plus x times the derivative of y squared, which is 2y dy dx, plus, and now I got to do the same thing here, but I'm going to have 2, and then I'm going to multiply it by the product rule. So this is going to be x dy dx plus y times 1 equals 0. And it says, what is the derivative at 1, 2? So it's looking for a number. If you have trouble with the algebra, I would plug in the number right now. Okay? Just plug in what you get. So y, everywhere I have a y, I'm going to plug in 2. So this is 2 squared plus x is 1 times 2 dy dx plus 2 times x is 1 times dy dx plus y times 1, which is 2 here. And that all equals 0. So this is 4 plus 4 dy dx plus 2 dy dx plus 4 equals 0. Everything that does not have dy dx is going to the other side. So that's going to be 4 plus 4 is 8. So negative 8. And then 4 and 2 is 6. Okay? That's what that looks like. Divide both sides by 6. And dy dx ends up being negative 4/3, which is B. Okay? So if you have trouble with the rearranging and stuff, there's a lot of problems where it says what's the number at this point, what's the slope at this point. Just plug it in. Just be very methodical about it. Okay?
You're all welcome.
Just be, like make the parentheses the variable and square it and whatever it asks you to do there. All right, number 3. Any questions on 2 before I go to 3?
That one's all right.
All right, number 3. If y squared minus 2xy equals 16, then what is dy dx? All right, so y squared minus 2xy equals 16. So this is going to be 2y dy dx. Okay, so I did the power rule, 2 times y and then times dy dx. Minus 2, and now I'm going to do the product rule. That's x dy dx plus y times the derivative of x, which is what? 1, equals 0. 2y dy dx minus 2x dy dx minus 2y equals 0. I'm going to send the 2y over there, and I'm also going to factor out a dy dx. Divide through 2y minus 2x. And I end up with dy dx is equal to 2y over, and I'm going to factor out a 2 because I have them in both of these terms. And what that allows me to do is to cancel the 2, and I'm left with y over y minus x, which is c. All right, any questions about that? All right. Number 4. This is a multiple choice problem, and it's one of our related rates. So the radius r of a sphere is increasing at the uniform rate of 0.3 inches per second. So dr dt, that's the change in the radius with respect to time, is 0.3, and it's increasing, so we're going to call that positive. Inches per second. At the instant when the surface area becomes 100 pi square inches, what is the rate of increase in the volume? Okay, so that's what we're working with. All right, so this is a sphere, and they tell you that the surface area is equal to 4 pi r squared, and the volume is equal to 4/3 pi r cubed. Okay, so on this problem they give us a hint. They tell us the surface area is 100 pi, and it'll allow us to find out what r is at that time. So this is 100 pi is equal to 4 pi r squared. Divide both sides by 4 pi. I get 25 is equal to r squared. So r is equal to plus or minus 5. We're going to go with the plus. And then on this side, I need to take the derivative of this. So dv dt, that's the derivative of the left side. 4/3 pi are all constant, so they're not going to change. And then I take the derivative of r with respect to time. That's 3r squared dr dt. All right, cleaning this up just a little bit. The 3's are going to cancel because I have one on top and one on bottom. I'm looking for dv dt. So this turns into 4 pi times r squared dr dt, and they told me dr dt is 0.3.
Well, if you just, I put the 3 and you put it in front of the R, I applied it to the 4/3.
Yeah.
Just made it 4.
That's fine. That's what this actually, when I crossed those out, it turned into just 4. So this is 100 pi times 0.3, which turns into what, 30 pi when I do all the multiplication. Okay? You'll feel okay about that?
That one, yeah.
That one. That one I do. Number 5. The area of a circular region is increasing at the rate, so dA dt, this is number 5, dA dt increasing at 96 pi square meters per second. When the area of the region is 64 pi, how fast per second is the radius changing? So dr dt is what I'm looking for. So the area of a circle is equal to pi r squared. When I take the derivative of both sides, dA dt is equal to pi times 2r dr dt. I need to know what r is. So I'm going to go to my area formula, and I'm going to plug in 64 pi for area is equal to pi r squared. Divide both sides by pi. I get r squared is equal to 64, so r is equal to 8. Now I plug in. So dA dt was 96 pi. This is equal to 2 times pi times 8 dr dt. So 96 pi is equal to 16 pi dr dt. And dividing both sides by 16 pi, I get dr dt is equal to 6. Any questions on that one? Feel okay about it? See how we're having to play with the formulas a little bit?
You start feeling good about the test right now, and then it just gets better for a couple minutes.
Number 6, the sides of the rectangle above are increasing in such a way that dz dt is equal to 1 and dx dt is equal to 3 dy dt. And put another way, dy dt is equal to what? 1/3 dx dt. They didn't give me that, but that might be useful to me, so I'm just going to write it down. It was easy to see. I end up with a triangle, and the x is 4, the y is 3, and they want to know what is the value of dx dt. So there's that. What is z? 5. This is a 3, 4, 5 triangle. And I'm going to do x squared plus y squared equals z squared. All right, so this turns into 2x dx dt, and that's what I'm looking for, plus 2y dy dt. And this is equal to 2z dz dt. Clean this up just a little bit. I could factor a 2 out of everything, right? Or I could leave it. Let's just leave it. So this is 2 times x, which is 4, times dx dt. And I want to leave dx dt in there because that's what I'm looking for. Plus 2 times y, which is 3, dy dt. Dy dt is 1/3 dx dt. equals 2 times 5 times dz dt, which is 1. That 3 and that 3 will cancel, so I'm left with 8 dx dt plus 2 dx dt equals 10. So 10, yep, 10 dx dt is equal to 10, so dx dt is equal to 1, which is B. Any questions on that one? Now, the moment you've all been waiting for. Number 7. A person 2 meters tall walks directly away from a street light that is 8 meters above the ground. If the person is walking at a constant rate and the person's shadow is lengthening at a rate of 4/9 meters per second, at what rate in meters per second is the person walking? All right, so let's draw a picture. That's 8. That's 2.
It's going to be a triangle instead of a triangle.
Okay. This area right here is the shadow. And that area right there is increasing at 4/9. Okay, this I'm going to call X, and this whole thing I'm going to call Y. So the shadow, which we'll call S, is equal to what? Y minus X. All right, so what we're going to do, these are similar triangles. That angle's the same, that angle and that angle are the same, and then these are both right triangles. So that means I can create ratios of side lengths. So 8 over 2 is equal to Y over Y minus X, which I want to go ahead and call Y over S, just because it's easier for me to work with that. Okay. Now I'm going to take the derivative. Well, let's do this first. This is 4 over 1 is equal to Y over S. So let's cross multiply. I get 4S is equal to Y. Why did I do that? Anybody know? Yeah, I didn't want to do the quotient rule on that. So I eliminated the quotient rule. So this is 4 ds dt when I take the derivative. This is dy dt. And what is ds dt? It's the shadow and it's lengthening, right? So ds dt is equal to 4/9. So this is 4 times 4/9, which is what dy dt is equal to. That's great, right? The problem is I'm not looking for dy dt. What am I looking for? I'm looking for dx dt. So I need another equation. Do I have another equation?
Yes.
Do I have another equation? What's the equation that I have? That's right. So if the shadow is equal to y minus x, then if I take the derivative of everything, ds dt is equal to dy dt minus dx dt. Okay, so I just found dy dt. They gave me ds dt. The only thing I don't have is that. So let's go ahead and plug. Well, I'm going to move dx dt over. And that's going to equal dy dt minus ds dt. So dx dt is equal to dy dt, which was 16/9, minus ds dt, which was 4/9, which turns into 12/9, which reduces to what? 4/3. Okay? That's the hardest problem on here, in my opinion. Okay? There was another way to work that. If you recognize that ds dt was the same thing as dy minus x dt, you didn't have to do that derivative up at the top. You could have just said, well, dy minus x dt is the same thing as dy dt minus dx dt, using properties of derivatives. All right, that's 7. Number 8. When the area in square units of an expanding circle is increased twice as fast as its radius in linear units, the radius is what? All right, so we need to make sense of that. First of all, it's talking about a circle. So what formula am I going to use for the area of a circle?
R squared.
That's right. And it says that the area is expanding twice as fast as its radius is. So when we're talking expanding, we're talking about rates, right? So the area is twice as fast. So that means 2 dA dt is equal to dr dt. Okay, that says that's increasing twice as fast as that. Take the formula of this. dA dt is equal to pi times 2r dr dt. And then, what are they asking? When the area, as fast as the radius and the radius. So they're looking for the radius. So I can either, what I'm going to do is I'm going to change this to dA dt over here. So I've got dA dt is equal to 2 times pi times r, and then dr dt is equal to what? 2 dA dt. I'm going to divide through by dA dt, and that's going to cancel out, and it's going to leave me 1 is equal to 4 pi r. Ow. Divide by 4 pi. And r is equal to 1 over 4 pi. Okay? Any questions about that one?
Not anymore.
Good.
Rich college education.
All right, number 9. Ship A. I'm going to do this like this if this is okay. I think I can do it a little faster. So ship A. Here's my picture that I've drawn. Ship A is over here, and it's moving to the left at 15 kilometers per hour. Ship Y is over here, and it's moving at 10 kilometers per hour. It says find the distance in kilometers between ship A and ship B when X is 4 and Y is 3. So A is basically just the Pythagorean theorem. It's walking you through this problem. This is what a lot of AP problems do. You need to know the Pythagorean theorem to do part B. So they're walking you through this. They're saying, hey, this is the right formula that you need to use, Pythagorean theorem. So x squared plus y squared equals z squared. So that's 3 squared plus 4 squared equals z squared, which is 5. Z is 5. B says find the rate of change in kilometers per hour of the distance between the two ships when x is 4 and y is 3. So derivative of the Pythagorean theorem. 2x dx dt plus 2y dy dt is equal to 2z dz dt. Okay, getting the feel for that. Plug in what you know. 2 times 4 times negative 15. That's all x stuff. Okay, it's negative because it's moving to the left. Plus 2 times 3 times 10, and it's all positive because 10's moving to upwards, is equal to 2 times 5 times dz dt. You've got everything. Solve for dz dt, you get negative 6. Okay, questions about that one? Okay. I have this, and you can pick up a copy whenever you leave. The only problem is I don't have 7 or
5, 6, and 7.
5, 6, and 7 on
Okay, that's okay.
it. All right. We good? You sure? Okay. Next one says, what about the angle? How much is this angle changing with respect to time? So I draw the triangle again. You could have used any trig identity you wanted to on this, sine, cosine, or tangent. I chose tangent. I don't know why I chose tangent, but I did. All right, so derivative of tangent theta is secant squared theta, and then I've got to take the derivative of theta with respect to time, so times d theta dt, and that's actually what I'm looking for. Then I do the quotient rule. X low d high minus high d low, so x times dy dt minus y times dx dt over x squared. Plug in what I know. Okay, and what I know is all of this stuff, and then I know that secant squared is 1 over cosine squared theta, so I'm going to multiply that by both sides, and I end up with this over here. Okay, so I multiply both sides by cosine squared theta, cosine squared theta, and I need that angle. I need to know what cosine theta is equal to, and I don't have the angle, and I don't want to go find the angle, and then, so what I'm going to do is I'm going to say to myself, cosine is adjacent over hypotenuse. The adjacent is 4, the hypotenuse is 5, so cosine theta of this angle is 4 over 5. I replace cosine squared with 4/5. I still got to square it. And then when I do all the math, I end up with 17 over 5 radians per second. And like I said, I have this for you, okay? And we're recording this, so you can go listen to it. You could have used sine, or you could have used cosine. It might have made the derivation a little bit easier. I don't know. Okay, what questions do y'all have on that one?
They'll be answered.
Go look over it a couple times, and if you don't understand it, come see me, and we can go through it slowly. Maybe if you want to try another way of doing it, derivation, like if you wanted to use sine or cosine or whatever, we can try that. Okay, number 10. I'll be here all day. Number 10, here we go. How many of you feel okay about implicit derivatives? Okay. Well, here's how I did the implicit derivative part of this, and they give you the answer. So you just have to get the answer. Do I need to go through this line by line? X 2y dy dx plus y squared times the derivative of x, which is 1, minus x cubed dy dx plus x times 3x squared dx dx, which is 1, and that equals 0. I've got to distribute this negative to everything over here, so that's where that one got a negative. I'm going to move anything that doesn't have dy dx over to the right, and then I'm going to factor out a dy dx on the left, and I end up with this. Dy dx is equal, or times 2xy minus x cubed over 3x squared y minus y squared. Divide through by 2xy minus x cubed, and I get this. B says find all the points on the curve. That means I'm using the original equation, which is this. Can y'all see that? That has an x-coordinate of 1. So let's do that first. So here it is. I'm going to plug 1 in for x, and I end up with y squared minus y equals 6, which I can move the 6 over and end up with this, and I just factor it. These are my x values, or I'm sorry, y values when x is 1. So I have 2 points, 1 comma 3 and 1 comma negative 2. Okay? So when x is 1, this is what I get. Y equals 3, and y equals negative 2. That gives me this point and this point. It may be. All right, so then to find the tangent lines, I need the slope. So I'm just plugging in 1, 3 into my slope, which is right here. And when I do, I get 0 over 5, which means the slope is 0. So I plug that point slope formula, which is right here. This whole side goes away and end up with y is equal to 3. When I multiply 0 by everything, that whole side goes away because I'm multiplying by 0. So y minus 3 equals 0, so y is equal to 3. I do the same thing with 1, negative 2. And when I do that, I get this equation. Y plus 2 is equal to 2 times x minus 1. So my slope turned out to be 2. Y is equal to 2x minus 4. Okay, and like I said, I have these, so I'm going to talk through them. Okay, the next one, C, says find the x-coordinate of each point on the curve where the tangent line is vertical. That's when the bottom is 0. Okay, so we're going to find when the bottom is 0, so I just take the bottom of it, and then I get this. So when x is 0 and when x is equal to 2y, x squared is equal to 2y. So y is equal to x squared over 2. I take that, I plug it back into the original equation, and I solve. I've eliminated y by doing that. Okay, so I plug this in for y, and I eliminate it. I do the math, and I get x is equal to the 5th root of negative 24. All right.